Imagine, for a moment, that our delicate blue planet, Earth, with its swirling clouds, vast oceans, and cradles of civilization, is not circling the life-giving sun at a comfortable 93 million miles away. Instead, the entire world and everyone you have ever known is now a moon, a satellite pulled inexorably into the gravitational embrace of giant Jupiter, the largest of all planets in our solar system. What would life be like? What would we see, feel, and understand? How would the grand ballet of astronomy, geology, weather, and biology be rewritten under the watchful eye of the solar system's king? To grasp the magnitude of this cosmic switch, we must first set the stage. In our own reality, Earth is the third planet from the Sun. It completes an orbit each year, maintaining conditions that have allowed life to emerge over eons. But as a moon of Jupiter, Earth would fall in among dozens of company, from fiery Io to frozen Europa, in a place far from the gentle warmth of the sun, and closer to the turbulent, roiling atmospheres of a gas giant that dwarfs our home many times over. Let's begin with gravity and orbits, the heartbeats of celestial mechanics. Jupiter resides, on average, more than 5 times further from the sun than Earth does. While Earth orbits at 1 astronomical unit, the standard measure of distance within our solar system, Jupiter lumbers along at about 5.2 astronomical units, roughly 484 million miles from the sun. The mirror-bright energy blazing down on Jupiter is only about 4% of what Earth receives, an initial sign that everything, from climate to agriculture, would be thrown into wild uncertainty. To become a moon of Jupiter, Earth would need to exchange its comfortable orbit around the sun for one around Jupiter itself. Suppose we keep things as plausible as possible, placing the Earth in a position analogous to Ganymede, Jupiter's largest moon, about 1,070,000 kilometers from its host. In this scenario, the day-night cycle is drastically altered, and the familiar waxing and waning of the moon would be replaced by the constant, immense presence of Jupiter hanging in the sky. Looking up, Jupiter would be more than 1,000 times larger in the night sky than the moon, filling much of the horizon, painting the heavens with its stripes and storms. Its cloud belts, whirled with browns, reds, creams, and whites, and the Great Red Spot, a gigantic hurricane wider than Earth itself, would all be visible to the naked eye, swirling in a slow, eternal dance. Now consider the implications for Earth's climate. At Jupiter's great distance from the sun, our planet would receive a fraction of the solar energy it's accustomed to. Daylight would be wan, thin, filtered through a frostier sky. Even the most sweltering equatorial regions would now be plunged into deep chill, temperatures worldwide dropping far, far below freezing. Without intervention, the oceans would freeze solid. Even the atmosphere itself would condense out, falling as crystals of nitrogen, oxygen, and water ice onto the desolated surface. Life on such a moon would face near insurmountable challenges. Plants need sunlight for photosynthesis. If the sun were a mere distant spark, even the hardiest of Arctic flora would struggle. For most life as we know it, this would be the end. The magnificent variety of terrestrial life, from rainforests to polar bears, would vanish in the cold silence. But let us not end the story too soon. Jupiter itself is an odd and active neighbor. The gas giant is not just a barren sphere of gas. It is, in its way, alive with energy, wielding a magnetic field that puts Earth's to shame, surrounded by belts of fierce radiation, and continuously flexed by the gravitational tides of its many moons. Might there be hope, despite the distance from the sun? Could the peculiarities of being a Jovian moon offset the disadvantage? We need only look at Europa, Ganymede, and Io, Jupiter's gigantic natural satellites, to speculate. Under the crust of Europa, tides from Jupiter's pole churn the moon's interior, creating warmth and, likely, a hidden ocean. Tidal heating is a powerful force. If Earth orbited Jupiter at a similar distance, it too would be subject to vigorous tidal flexing. The solid crust would rise and fall dozens of meters each day, creating friction and thus heat. This energy could, just possibly, offer Earth a chance. Deep below the surface, tidal heating could melt ice, reawakening pockets of water. Subterranean lakes and perhaps even seas would bubble with warmth, and geothermal vents might nurture entire ecosystems, much as they do today in the darkness of the mid-ocean ridges. On the surface, however, life as we know it would be relegated to the past, replaced by a frozen, windswept wasteland. Maybe, over millions of years, life could recolonize such environments, evolving to flourish in the pitch black, deriving energy not from the pale sun, but from chemistry and heat oozing up from within. Might forests of fungi, mats of bacteria, and creatures adapted to darkness and cold find new dominance? The impact on our day length and calendar would be profound. Earth, no longer in a one-year orbit around the sun, would now circle Jupiter, perhaps in Ganymede's orbit, taking just over 7 Earth days for a full circuit around the planetary giant. The familiar 24-hour day, defined by Earth's rotation, might persist, but the overriding rhythm of the world would instead be the Jupiter month, just a week long. Seasons, as produced by Earth's axial tilt and solar orbit, would all but vanish. With our former year reduced to a weekly sidereal period and sunlight diminished to a wisp, the concept of summer and winter would fade into irrelevance. Instead, tenuous, eerie twilights and perpetual cold would reign, punctuated only by the occasional glow of Jupiter's aurora and the massive volcanoes on nearby Io, visible as sparks in the dark. And what of the view? Imagine standing beneath the sky at night, under layers of insulation and protective gear. Jupiter would loom as an ever-present titan, flooding the heavens with its banded glory. The sky would also be alive with the dance of other moons. Io, Europa, Callisto, and Ganymede would be punctuating the stars, some outshining even the planets we know, moving in smooth clockwork paths. Eclipses would happen with stunning regularity, one great moon passing before another, or Jupiter plunging entire regions of Earth into shadow for hours at a time with its immense bulk. And always, the gas giant's own magnetic field would interact with the million-mile-long trails of plasma from the moons, producing auroras brighter and wilder than any ever seen on Earth today. Now consider the consequences for geology. Continuous tidal flexing would cause earthquakes on a scale unknown to modern humanity. Chains of supervolcanoes might become commonplace, as the crust is torn and rippled by the relentless push and pull from Jupiter's mass. Mountains might be forced upwards and then worn down by endless ice, forming landscapes as alien as those seen on Europa or Titan. And the magnetic environment? Earth, now trapped within Jupiter's formidable magnetic field, would be subject to floods of radiation. Any living thing on the surface would be bombarded by charged particles. Only deep beneath ice or rock would protection be possible. Even our own atmosphere would be stripped and altered, glowing in surreal daydreams of color, or perhaps withering away entirely under the onslaught. But humanity is nothing if not ingenious. Let us suppose that somehow life and civilization had managed to adapt to these new circumstances. Perhaps underground cities, built kilometers beneath rock and ice, would be our new home. Geothermal energy and the electrical power of tidal movement would drive our machines. Artificial light, generated with ever more creative efficiency, would sustain crops in buried biodomes. The external world would be a forbidden realm, harsh and silent, while below, an industrious race of survivors would cluster in insulated warmth, preserved against the void. Our very sense of time and space, of day and night, would change. The society that might arise would be fundamentally different, shaped by the constraints and demands of a Jovian tide-powered world. Festivals to mark the passing of Jupiter overhead, calendars based on moon alignments, and art inspired by the ceaseless tides and alien auroras would emerge. One can only imagine how our myths, philosophy, and religions would reflect these changes. Perhaps Jupiter would become the supreme deity, a literal god whose presence filled the sky, whose moods were manifest in storms, electromagnetic fury, and seismic upheaval. The sun, now a dim and remote thing, might be relegated to the place held by the older gods, the titans of a forgotten age. Interactions with other moons would be frequent and potentially hazardous. Io, for example, is a world rocked by constant volcanism, its plumes visible across the sky. Collisions between fragments ejected by nearby moons and Earth's upper atmosphere could pepper our world with meteoric debris, causing spectacular light shows or even catastrophic impacts. From time to time, the relentless gravity of Jupiter and the other moons could nudge Earth into orbital resonances, forcing changes in the length of the month, shifting tides, and perhaps even threatening to tear our planet apart. In extreme hypothetical scenarios, tidal disruption could transform Earth itself into a new ring of debris, arcing in glittering bands around Jupiter, a sad echo of Saturn's own icy adornments. But let us step beyond practicalities and contemplate the profound awe such a cosmic landscape would inspire. Would poets wax ecstatic about the cyclopean gaze of Jupiter, forever vigilant in the heavens? Would children learn star navigation by charting the procession of moons rather than stars? Or would entire cultures arise around the precise timing of eclipses and the dance of auroras? In science and imagination, the idea of Earth as a Jovian moon opens new directions for thought. As we peer into the possibilities, we must also recognize that our own position in the universe is rare and precious. Our planet exists in a unique balance, a Goldilocks world, not too hot or cold, blessed with sunlight, water, and a relatively stable orbit. If Earth were a moon of Jupiter, the conservatory of life would be forced underground, and the intricate web of species would be redrawn from scratch. Outward appearances would be harsh, inhospitable, a planet of blue ice, black skies, and titanic storms ever looming. But perhaps somewhere, in the warmth of a subsurface sea or a volcanic vent, life could find a foothold again, persisting in the darkness, hungry for warmth and connection. As we draw this vision to a close, one must acknowledge the incredible web of consequences that bind orbit, light, heat, chemistry, and life. Our existence is not guaranteed by right, but rather the product of cosmic serendipity, a marvel brought about by the stable, sunlit orbit we know today. To imagine Earth as a moon of Jupiter is to appreciate, all the more, the fragility and uniqueness of our world. Yet, in that imagined world of cold beauty and stormy awe, perhaps another kind of life, resilient and adaptive, could rise anew. Whether that life would be us or something altogether different, it would be shaped, as the tides shape every world, by the great powers above. And as humankind continues its own reach into space, seeking new homes among the stars and planets, it may be that the lessons of living as a satellite, dependent on ingenuity, shelter, and one another, will serve us well in worlds yet unknown. For to imagine Earth as a moon of Jupiter is not just a thought experiment. It is a reminder of possibility, adaptation, and the boundless reach of imagination, wherever we may find ourselves in the unending vastness of space.